Jeff Minton, the current president of Make Lehigh Valley, and doing some work making game pieces.
Very cool. Can you show us what you're doing?
Yeah, so here's some of the, I'll just start with, this is the first one I made.
Okay.
And this is mostly just to make sure this is looking right to you. So you have the, the legs.
Right.
And then to give it what you had with the different depth, there's actually, this is going to be lower in the front.
Right.
And just want to first make sure that this is going to look the way you want it to look and feel the way you want it to feel.
Right.
And I took the measurements from the
prototypes?
the prototypes you made, yeah.
Okay.
Yep. So I also have, right, looks like that.
Okay.
And then left, basically very similar to right, just the arrow coming out the other way.
Yes.
The start flag, like that.
Okay.
And then the step.
Cool.
Like that. And the easiest one, by far, was this, because all it is an octagon. And octagons are really easy to make because there's just a create octagon thing.
Oh, so you had to write code to...
Well, so this is something called Openscad.
Okay.
This is just another 3D modeling, computer-aided design program.
Okay.
Me being a software engineer, I like it because it's specifically, the whole idea of Openscad is that you are writing code that is of their language they've worked on to make your pieces. So it just makes more sense to me to work on it that way.
Cool.
Yeah. So this is one kind of CAD program that uses this language. Printing. That's it. Yeah. Well, it's not just for 3D printing. It's for any kind of computer-aided design, any kind of modeling at all. All we do then is we actually compile and render this, and then export it to an STL. And STL is the format that the 3D printer uses. So that's a specific 3D modeled file type that the 3D printer can understand and use to make the pieces out of it. Yeah. Yeah. So the way this works is it puts down a layer of plastic over and over and over again.
Okay.
Until you've made an entire thing out of it. And the little circle things, what that does is it just it's what's called hexagonal infill, and it's just a way to give the inside structure, but using a lot less plastic. Instead of just making lines over and over again, it uses a lot less plastic to do those insides that way. Well, the way it works is there's a little tiny thing on the bottom there, and that's basically like a really, really hot glue gun or something like that. And it has a really tiny hole in it, and what it has to do, it has to draw each shape over and over and over again, and it puts a layer of plastic down, and another layer, and another layer, and another layer, over and over and over again until you've made this. You can kind of see here it's made of many, many layers of plastic. So you have to draw the entire shape each time. And the circles on the inside are just to give it, strength, to make it, a solid piece, so it doesn't fall apart at all. When you're cutting it two different ways. One way is vector, one way is raster.
Okay.
Vector works by just giving it lines, and it just moves the laser along those lines.
Okay.
Raster works like the pixels on your computer screen, where it'll actually just put a pulse in for every pixel, and it'll go across and back over and over and over again. And what that does is it lets you carve things, so you can get a big chunk out. So you can actually draw letters or such on an object, but you don't go all the way through. You're just going part of the way down. Yeah. I'm gonna do 10 millimeters per second. It's gonna move that fast, and it's gonna have 50% total power. This should cut it through all the way once. If not, I just hit cut again and it gets through the rest of the way.
Okay.
So I'm actually just gonna go and
This is wobbly.
do this.
Yeah,
now.
but you stand straight. You don't dance, okay?
All right. So here we go. I'm gonna start.
Okay.
Let's watch it do it. So you can't really see much happening. You can see the line it's making afterwards. Yeah, it's not cutting all the way through, so I'll have to cut it one more time.
Okay.
It's tough to tell what power you need to get through what kind of material.
Right.
This is just acrylic plastic, basically plexiglass.
Do you want to share with us, like you did last time, how this works? Like you were talking about carbon dioxide
So,
and stuff like that?
it's a carbon dioxide laser, and I'll show you the actual tube back here. You want to come around this side.
Yes.
So the way it works is in this is the laser tube in here.
Okay.
And so there's carbon dioxide inside of here. And then there's a connector there, and there's a connector on this side, and it puts a lot of voltage through it. It puts a lot of power through it.
Okay.
And what it does is it excites, that's what it's called, it excites this carbon dioxide, basically makes it start to glow. Then it bounces on mirrors that are either side over and over again, back and forth, until it is perfectly in a straight line. And then since the mirror on this side isn't completely a mirror, it lets things go out of it that are going in a perfectly straight line. So it bounces here on a mirror to there, over to there, and then down onto the piece. And then you can tell when it's cutting because you'll start to see smoke come out the bottom. But it's not doing that yet, so we'll probably have to do it one more time. But see, this is a lot faster than the 3D printer.
So exciting.
I'm excited.
Are you?
It's really cool.
But this does not need any programming for you.
Well,
to...
I made the shape the same way I made those shapes. It's just instead of a 3-dimensional thing, this is a 2-dimensional thing. And really, you don't need to do the programming. It's just that's the modeling tool that I know how to use.
Will the blind folks be able to feel it then?
I think they'll be able to just feel the shape of it itself. They'll know what it feels like with those edges on it.
Oh,
And
yeah.
one more time.
Because they can put their finger around it, right?
Yep.
It's not working.
It is working. It's just taking a little time to first draw it, and then it's going to cut it.
Well, it's actually cutting it each time. It's just
Okay.
cutting it
A
a bit of the way, and then a bit more, and then a bit more, and then a bit more. I probably just needed to do full power from the beginning, and it would have been fine. But yeah, I'm gonna still need to cut it one more time.
So that's the picture, Kay. Do you see that? That's the picture. It's cutting there.
Wait, it's done it already.
So what happened is I didn't tell it to go. I didn't tell it to use enough power. So what it's doing now is it's kind of it's getting through part of the plastic, and then a little bit more, and then a little bit more each time. Almost through.
Look, it actually...
Yeah, that one
Cut it.
fell. It's really close. Like one more time, it'll finish it out. So this way I know that this is about 4 runs.
Okay.
I did it at 50% power and 10 millimeters per second. So if I do it 5 millimeters per second at 100% power, it basically will do this
Just
4
once.
times. Yeah, it should go through all at once then. Yeah, but you can see, so it's hard to tell, but there's actually, there's some smoke coming out underneath the piece now.
Yeah.
And what that means is that it's working right.
Right.
Because there's a laser, there's also, coming out right around the laser is actually compressed air. There's a pump back there that pushes air straight down. And what it does is it blows all the stuff away that you've just cut, so it doesn't get in the way again to cut anymore.
Did you look that it cut and it's just let that piece go inside?
Yeah.
Okay, what would you like to cut with a laser printer? Or what would you want to make with a 3D printer?
Toys.
Yep. One piece fell out.
Toys? What kind of toys?
Some funny Transformer toys.
Transformer toys. I'll show you one thing we made on here.
Ooh, that's so neat. It cut it out.
This is someone made a cat chess set, and someone made Pokemon.
Look at that.
Okay, that should be done now.
Okay.
Yep, they're all falling out. Gotta get one piece that fell down.
So now, okay, close your eyes and see if you can feel the pieces.
Yeah.
That's how our friends will feel it too.
I feel it.
Yeah? What does that feel like?
Wait.
Feels like what?
This must be a flag.
That's correct.
See, then the paper actually comes off.
Yeah.
The paper is just to protect the plastic, so when you get it shipped to you, it doesn't get scratched or anything.
Oh, okay, cool.
Yeah.
I can't even
Comes
tell
off
what
really
that
nicely.
is. Ooh, this must be an octagon.
Yeah. What shape uses an octagon? Sorry, what okay, what shape in our code uses an octagon?
What shape in our code?
Yeah, you tell me.
The stop sign.
Got it.
I'm sitting. Guys, look at they're standing. I'm a big step.
So these will actually fall out too, so you'll have just the actual
Right.
that thing. Yeah.
Neat.
Cool.